Welcome to the Security Discussion Panel. My name is Gregory Lebovitz. I am a security executive and moderator of today's panel. We're going to be talking about the problem of secrets management, and specifically how we started dealing with this problem. We're going to be doing that today with the help of some HashiCorp customers and also some of the earliest technologists at HashiCorp in this area. Let's go ahead and get started. Our customers that are with us today are Rob Cameron, who is the Technical Director of Infrastructure at Roblox and also a very long-term and dear friend. We worked together at several previous posts. And then also we have with us Sarah Polan, who is the Secrets Management Architect at ABN AMRO. Welcome, Sarah and Rob.
Thanks for having us, Gregory.
Thanks for having us.
Yeah, sure. Well, let's go ahead and dive in. Our other two panelists will introduce right as they start to speak in a moment. So Rob and Sarah, so glad you could be with us again. Tell us a little bit about how you personally got into this whole area of secrets management. Like, what was the problem that you were addressing when you started going, I think I need some product in this area to help me? And how did you go about getting into it?
Sure. So I started at Roblox in December 17, and our goal was to look at some more modern architectures around infrastructure. And one of the areas we struggled with was secret management, surprisingly, as we're here to talk about. We had several different tools that utilized ability to store secrets, keep them in a specified location. And while they definitely worked for us very well, they just didn't have integrations from an API perspective, the ability to easily pull information out of them, out of the secret system, and then being able to inject it into various jobs. And so this helped us look at several different solutions, which of course we ultimately ended up with Vault as our secret management product.
That's cool. Sarah, how about you?
Yeah, I think on our end, it was really this need to sort of centralize secrets and make sure that we didn't have a secret sprawl problem. We have so many development teams and so many people using various types of secrets that we really needed to get those into one place, platform independent. And especially with this rise of containerization and containerized workloads, we really wanted to make sure that everything was secure as possible. And so when we were looking for various products, when we did the proof of concept for Vault, we were really keen on the secure multi-tenancy that we can get with the enterprise namespacing. Also, the dynamic credentials we really liked because, that reduces our attack surface greatly. Also, the fact that it's API driven and we can automate it as much as we want to or as little as we want to. In our case, the less hands-on people are with secrets, the happier that we are. And then definitely something that was a major consideration for us was the fact that there's such a huge community around Vault. And the developer community, even if we're using the enterprise product, can still reach out to the open source community and get a lot of the information that they need to be able to automate and really optimize an integration with Vault.
So that was an interesting comment about open source. Rob, Sarah, did you start with secrets management using Vault open source, or did you start with the commercial version, the enterprise version?
We started our journey for all of our HashiCorp products on the open source side, and we found that right out of the gate we got an amazing amount of capabilities from the product itself, but we wanted to get a little bit more for things like namespacing, to be able to have deep support for some of the use cases that we wanted, as well as some more of the advanced high availability replication features, and that helped us drive into enterprise. And what I liked with it is we could really do everything out of the gate with open source, but effectively we grew into enterprise where those needs became apparent, and it was an easy transition for us to be able to start utilizing it in all the more advanced feature sets.
For us, we went straight for the enterprise product because of the government regulations and internal regulations that we have in terms of data security. we were quite limited and really needed that secure multi-tenancy from the beginning. So yeah, we could run hundreds of different Vault instances or just opt for the namespacing. And that really helps us just control everything. We know that the policies are being applied correctly to each namespace. And if there's ever any issue with an application or a specific secret, we know that that's not going to affect our entire ecosystem. It's just really limited to that one thing. So that was really the driving factor for the enterprise as opposed to the open source.
I want to introduce two other people. These folks are HashiCorp employees and have been with the company for quite a while. Jeff Mitchell is the principal engineer at HashiCorp. He was one of the first developers on Vault. And Andy Manoske is principal product manager at HashiCorp, and he was the first Vault dedicated product manager. Jeff and Andy, welcome. Sarah, I want to go back to something that you mentioned when you were kind of sharing how you got into secrets management. You mentioned this term secret sprawl. Can you describe for our audience what you mean by that? And maybe give me a practical example of when that did happen actually in your environment or a previous environment you might have worked with Vault in.
Yeah, sure. I think secret sprawl is something that most organizations, especially if they have more than one system running, kind of deal with. And that's, where do you keep your secrets? Those API keys and your certificates, it's really easy to, end up with some in the source code and some in GitHub. If you're running a multi-cloud platform or a hybrid platform, then maybe you end up with them in KMS and Azure Key Vault, and there's no kind of unified spot for you to keep your secrets. Whereas when you're presented with Vault, it really gives you the opportunity to keep all of those secrets in one place. You know exactly who's accessing them, which workloads are accessing them, how they're being accessed, how long have they actually been there for. And the challenge with dealing with secret sprawl in an organization is that you don't have any control over that. So you don't know how many people have seen them or how long they've been in play. So really getting rid of that secret sprawl is something I think that's quite critical to most organizations. And it's not limited to the financial industry or the technical industry. It's anyone that has any kind of systems really needs to address the secret sprawl issue.
And in addressing it, do you end up getting sort of a record or a trail of kind of everybody or every machine or every process that's touched a secret? And is that anything, like I know there's a ton of compliance issues in financial industry. Is that something that has to happen for y'all, or is that just something that you prefer to be able to just have a higher level of security?
At any given point, I know particularly with PCI DSS, which is the credit card compliance, you have to be able to track all of these users at any given time and make sure that you know essentially which secret is being leveraged by which user. Now, whether that's a machine or a person, it really doesn't matter, but it's really part of this whole overall compliance. Now, you can argue that it's part of that regulation, but as you see more and more data attacks and data breaches, it's really something that everyone should be paying attention to, and it's not just limited to the financial industry.
I got it. I just wanted to clarify one thing. You mentioned like certificates. Are you actually storing the certificate in Vault, or are you storing something else about the certificate in Vault?
So for teams that aren't quite ready to move on to these dynamic certificates, which we really would love, especially within the Kubernetes workload and any containerized solution, they're just storing the certificates themselves. So usually they're third parties that have authorized these certificates, and then they leverage those just as a static secret. Not quite as advantageous as a dynamic certificate would be, or using Vault for that PKI. But as long as it's contained, then we consider that a step in the right direction.
Okay, and then that's the actual private key. I mean, the public key can be passed anywhere, anytime. We don't care, but so it's really the private keys that we're thinking about there when we're talking about the certificates and the chaining.
Yeah, it's the private keys, but also as long as we know where that public key is and we can trace that public key, then we're happy also to use Vault for that.
I think there's a, if you don't mind, Gregory, I was going to say,
Yeah,
I think that there's a lovely like crawl, walk, run story. We like to say crawl, walk, run at HashiCorp to describe sort of the journey from on-prem to cloud, or the journey from, getting to, from like static secrets more towards dynamic secrets. And I think that really exemplifies how that works, right? You have teams that aren't able to actually get to that point where they can dynamically generate secrets and consume those. And so in the meantime, you have a solution in Vault that can, that can help you, that can tackle that workload that you have. But when you're ready to like take that next step and generate certificates much more dynamically and for shorter lifetimes and more ephemerally, then Vault is also ready to do that as well. And we've tried to make sure, over the years that we're really addressing all aspects of that sort of crawl, walk, run cycle, so that, you can always sort of continue your journey to better security, but Vault's always there to sort of help you and be ready for you to do what you need to do at that point and at that stage.
And I also think what's interesting about this is the fact that when you look at sort of traditionally how certificate management and public key infrastructure worked, these were in many ways different products, right? These were like independent solutions that would ultimately be the result of like an independent team. There would be an independent way to be able to deploy that solution, to attribute identity and access rights afforded to it, etc. And I think this really highlights one of the most exciting parts about Vault is that Vault treats secrets management as a holistic problem. It's not, I need to protect one secret differently than the other. It's that all secrets are protected with an aggressive level of cryptography that's simplified from a development point of view and from an operator point of view. But at the same time, we respect that there are different workflows associated with different types of secrets. So if you are ready and able to adapt to a certain workflow, what Vault can do is Vault can automate a lot of that workflow. And there are a number of like usability reasons why this is important, but I think from a security perspective, what we're most excited about is the fact that it mitigates side channel attacks. And a side channel attack is an attack that is used by an adversary to circumvent cryptography. So rather than going through the math associated with how you make it difficult or computationally intractable to break information and break encryption, you go around it. You exploit a flaw in how the mechanism to handle keys, handle the creation or decryption of that cipher is used, etc. And so, the PKI engine, I think, really well highlights this, where, the different secret engines within Vault, which are just another way of saying the different ways that Vault understands that there's a specific type of workflow and tries to automate as much as possible that workflow associated with a specific type of secret, really highlights the fact that what we're trying to do when we build Vault is minimize side channel attacks by taking away the complexity associated with how I would keep secrets protected within the context of that workflow. And so I think it's really interesting, at least because it highlights the fact that it's not just PKI, but it's a whole host of mechanisms that exist within Vault to protect uniformly secrets to a very high degree of security, but at the same time simplify the process such that an adversary couldn't exploit complexity inherent to that workflow that the secret would be used in.
Yeah, that's kind of hearing the history of that and how you guys saw the problem, you and the rest of the development team saw the problem as it was emerging is kind of fascinating to me. Rob, what are some of the things that today you're addressing? You're right in the middle of working on these particular challenges or these particular problem sets with Vault.
Sure. So surprisingly, and I always joke, is secret management is obviously a big part for us, is being able to put static secrets in. We primarily utilize Vault with HashiCorp Nomad as well, so that way when we build out jobs to run in the orchestrator, it can go ahead and pull these secrets, whether they're like Slack API keys or other standardized elements. One of my favorite uses is...
And maybe just give us like 10 seconds on what does Nomad do for you?
Oh, sure. For us, Nomad is our primary orchestrator versus Kubernetes, and we utilize it to run somewhere around 50,000 containers today in production and across, I think, 24 different clusters. Correct. And it actually powers as well all of our game servers. So we don't necessarily run the games themselves inside of Nomad, but we use our own custom matchmaking orchestrator and manage its global deployment using Nomad. And before we had done this primarily on Windows, again, worked really well for us and a good solution. But migrating over to Nomad took global deployments, for example, from 45 minutes down to sub 10. And then we can actually do game updates using this system to do instantaneous updates, so we can just spin out any game game instance types that we want at any time. So Nomad overall has been very huge for us, and a little bit different than the world of Kubernetes. We still do, and I love Kubernetes, and it's running here next to me, but just unfortunately we can't always be together for just based on the technical requirements that we had in the organization.
All right, so getting back to you're running Vault and secrets management with Nomad, and that's where I interrupted you, sorry.
Oh, no worries. A big part of it, too, is the dynamic Pki certificate. So using Vault's templating engine, we can just go and specify all the certificates that we'd want to be able to put into a job. And from this, we can start up a new instance of whatever service we want, whether it's like, say, Telegraph for ingesting metrics, logging, whatever it may be. We can spin up certificates per job and then have Vault manage the entire lifecycle for them. So to me, what I love about it is the best secret that you have is the secret you never have to see or expose. They're automatically generated, injected into the job, consumed, and then updated. And as part of an interesting thing, we actually run the HashiStack Nomad console and Vault on top of Nomad itself and for our POP locations. And so the certificate or TLS for console, Nomad, and Vault are actually automatically managed through Nomad and through Vault. And so they actually rotate, I believe it's, once every few days to once a week, depending on the needs there. And they just have run for almost 2 years now, actually, at the end of the month. And so surprisingly, we've never had to touch those certificates, know what they are. They just continue to spin up and continue to go with us, which is really awesome.
So just on that real quick, with the whole dynamic certificates, there's basically not the opportunity, or maybe I should say the opportunity for an attacker to be able to breach, explore, move laterally, identify where those keys might be, or a system that's using those keys in memory right at the moment, and then grab the key. That time frame is just really small, it sounds like.
It's very small, and also the way we use it is that each POP has its own certificate authority set. So in the event we're ever even concerned that there's a breach or anything that could have potentially happened, we can rotate the entire HashiStack for a specific POP, including all the TLS, including the CAs. So even if the CAs were breached for any reason, within a half an hour, so that way we can just spin everything out and just replace everything in that event. Knock on wood, that has not happened, but you always want to have, I like to think of like collapsible sites. So if there's any concern about breach, you're not necessarily pausing and like looking at every machine for 20, 30 hours to do forensics. You can just say, hey, let's wipe the entire site, and we don't have any issues or concerns about certificates or anything being leaked, which is really fantastic for us.
Wow, that's a cool use case. So you were about to share another one.
My favorite personally, and it's kind of silly, but I love it, is this SSH key signing. So I set this up when I initially rolled out the game servers around 2 years ago, so that way we could have users securely access the hosts. And we just didn't end up using it and productionizing it, but we ended up getting around to it like last fall, and we enabled developers or admins to be able to get into the servers dynamically using the signed SSH keys. And what I love about it, as opposed to managing keys and rotating them and having all sorts of software do it, they get the signing, we have the authorization in the Vault audit logs, and then when they SSH into the host, they have the authorization around which user was signing in based upon what was signed on the certificate. So the user can use their own keys. It doesn't particularly matter to us. They just get the authentication validated through the SSH signing in Vault, and it's very simple then for them to go ahead and access. And I even set up a cool SSH type of proxy solution, so that way if you're accessing a very far POP that's 200-300 milliseconds away, you get a little bit of TCP acceleration with a middleman service as well. And what I love about it, again, it's just a few commands to get off the Vault, get your certificate, and then boom, you're ready to start administering and going all over the world to do what you need to do. And mostly people that use this are non-infrastructure focused, more users or developers of the game system, and they seem to really like it.
Andy, I don't know if you caught that, but we got to think about maybe productizing that.
We'll get right on it. But actually, Rob's points here really well tie back, and Sarah's too, to something that I think is really important here and has been very fundamental to Vault from the very beginning. In fact, I believe some of these are secret engines that Jeff himself personally developed. Is that when we talk about protecting secrets in flight and at rest, and really holistically protecting secret workflows, one of the best ways we've learned throughout the development of Vault has been to use dynamicism. And what I mean by saying use dynamicism and introducing buzzwordy kind of speak is the fact that, we think like an adversary does when we try to define how we protect secrets within Vault. It's a technique that we call adversarial modeling. And when we build Vault to protect against adversaries of a very wide degree. Both in open source and enterprise, we try to protect against well-resourced adversaries that we assume are able to circumvent the exterior protections of a system, able to get into your network, able to eavesdrop potentially on, ciphertext that's being transmitted between Vault. Assuming that this is all the case, one of the things that's very important here is the fact that we minimize the transmission of long-lived stateful details, credentials, certificates, etc. And the best way to ensure that an adversary couldn't theoretically breach various layers of security and cryptography and steal credential is to generate credentials or details that are very ephemeral. They're very short-lived. They expire very, very quickly. And that dynamic credential creation process or dynamic certification process is something that we think is very, very important, not just within the context of these different types of PKI workloads or secrets management workloads, but really across Vault. Anytime we are trying to generate a credential or something that we know you're going to use is very sensitive, we want to make it as instantiable and minimize sort of the expiry period or minimize sort of the period that it is usable as much as possible. I think the best example of this is certainly the dynamic credential process that we were talking about, where if, for example, I could have Vault protect your secret key for AWS and ensure that only the right users are given access to it. But there's a challenge that if one of those users is fraudulent or somehow the cryptography protecting it is circumvented, that credential could be used to breach your entire system. So rather than giving you the keys to the kingdom, what we can do is use the keys to the kingdom to be able to create very short-lived, very scoped to a specific workflow credentials that could theoretically be stolen and not sort of give access to an adversary into your entire infrastructure. And I think one of the things that I'm really excited to hear Sarah and Rob talk about is the fact that this is a valuable sort of proposition, because this isn't just a Vault problem. This is a security problem worldwide, that we need to get away from sort of taking out the keys of the kingdom every single time we try to go open the car door. What we need to do is start moving away from long-lived, very powerful static credentials and instead keep those very protected while creating dynamic credentials. And this is something that I know Jeff, as well as Mitchell and Armon, were really passionate about from the very beginnings of Vault. But it's something that we continue to focus on today as we learn more about use cases like Sarah's and Rob's, where this is a place where we can minimize the ability of an adversary to be able to steal very sensitive information and cause more data breaches.
I think it fits in quite nicely with this this kind of mindset that as you move to this multi-cloud, hybrid cloud, you really just have to assume breach. So we're no longer, yes, we need to try to stop breach of any kind, but we also really need to be looking at what happens when we are breached. And dynamics, in my opinion, are something that are incredibly powerful and really limits how much access somebody would ever be able to gain to any given database or certificate or cluster, just because they're constantly rotating and they're constantly assuming that something has been breached or compromised in some form.
So we release Vault on the enterprise side about a release per 4 months. So in the last 8 months or so, version 1.4, 1.5 have both come out. Sarah, are there a specific feature or two that's been something y'all were waiting for and you're glad for, and either you've now put into practice in 1.4, 1.5, or you're about to?
Yeah, so integrated storage for us ended up being a complete game changer because it allowed us to...
And what does that mean? What is integrated storage, and how is it different than what it was before?
So instead of using console as a backend, we can just use Vault and its own storage to store secrets and make sure that everything is stored adequately with enough redundancy. When we were using console, as much as we love console, it took more nodes, essentially. And because of our limited infrastructure, because of various requirements and regulations, it was quite difficult for us to auto-scale something of that size. So once we could reduce the console nodes and just come down to running Vault, and the storage was already built into that, it allowed us to auto-scale and really have a more auto-healing sort of setup. Another thing we really like with 1.5 is the Splunk integration. We have a great engineering team, but like any engineering team, our resources are a little limited. So to have metrics and logging just completely available to us at the drop of a hat saved us a lot of time and headache, and means we don't have to keep up with that infrastructure change and the constant updates that can occur with running your own logging and infrastructure on that side.
And Andy, Jeff, what have you seen customers, maybe something different than Sarah might have said, anything else that you've seen that's customers have found really interesting in the last 8 months or so?
So I think first, one of the things that I'm most excited about hearing about with Sarah is the fact that these are features that, integrated storage as well as the Splunk integration that we originally did not think of. These are the result of feedback both from the Vault Enterprise community, the open source community, as well as new members that joined the team. So my colleague Darshana on our team actually spearheaded the initiatives to deploy integrated storage as well as a Splunk integration. And much of that was guided by her research with newer Vault Enterprise users as well as prospects, the open source community, and her own personal experience previously coming from a background in like metrics and integration. And I think this really highlights the evolution of the team. There was a time when Vault was Jeff, one of our software engineers, Armon actually still continued to code very aggressively at this time and actually developed a significant portion of replication. Various people in the company that would jump in and out of GitHub to kind of like throw in code, and myself. And that really well showed a time of Vault where we were guiding based off of our previous experiences. Today, Vault represents the experiences of hundreds of Vault Enterprise users, an open source community that has tens of thousands of users, and a growing team that has a very diverse set of backgrounds and perspectives on how we ultimately march towards this future of better protection of secrets. So it's exciting to hear that these are valuable features because these are things that were not part of the original plan in some cases. In terms of other features in Vault 1.5 that are very interesting, I think one of the things that we've seen a lot of uptake with is something called the Transform Secret Engine. And the Transform Secret Engine is a secret engine that was part of an initiative that we call the Advanced Data Protection Package in Vault Enterprise. And what ADP really focuses on are how does Vault protect workflows that live outside of the barrier of Vault, the cryptographic barrier, what we call, that is ultimately sort of the exterior protections of Vault. I think one of the things that both Rob and Sarah talked about was that Vault serves to protect very sacrosanct secrets that live within the context of a diverse multi-cloud infrastructure. Well, in that case, we really have seen since the beginning of Vault, Vault is the, we call it the bulletproof vest you wear in the tank. It is the last line of defense between an adversary and very sacrosanct information. And so it's easy to defend, for Vault to defend itself when it is a bulletproof vest in a tank. But what happens when I need to throw that bulletproof vest on someone that lives outside of the tank, outside of the protections of your infrastructure, and outside of what things Vault can control? And that's what the ADP module is for. Transform is a secret engine that allows you to protect data that lives in a workflow and resides completely exogenous to Vault. So how do I protect data like credit card numbers, social security numbers, and in a variety of different forms, in a variety of different workflows that is going to reside outside of Vault's cryptographic barrier? This is a 1.5 released a number of kind of capabilities around simplifying the process for, as a developer, using that workflow to protect any kind of secrets, especially within the context of using format preserving encryption, which is a very fast growing area of cryptography, to protect and automate the protection of those secrets that might reside within like a file system or a database or splayed across multiple clouds. And it certainly has seen a lot of uptick in, since its release in 1.4 and 1.5 because of the fact that, again, it like every other feature within Vault, it focuses on how do I adapt Vault to protect what I've already got. I already have security infrastructure, I already have tooling, I've already got a diverse set of places where I store data and use data. How do I just make sure that regardless of where it sits, I can have Vault protect that and automate that data such that I don't need a PhD in computer science to be able to instrument a deep cryptographic infrastructure?
So let's, we just have a few minutes left. I want to shift to the future. Jeff, Andy, maybe start with Jeff. We have this open source community. They're giving us feedback. We have our enterprise customers. What are we seeing on the horizon? What problems are people trying to solve that, no roadmap commitments, no, we're definitely doing this in this timing, but what do we see are some of the problems in the next 2 to 3 years that we think are important for us to be paying attention to and to be looking at?
So one of the things, obviously, is human-to-machine interaction. And this is where Boundary comes in. One of the things that we really saw going forward is...
Boundary being a new product that we just
Boundary
introduced.
being a new product that's dealing with what's called software-defined perimeter. That's sort of the one name for it. But really it's about gating access to network resources with just-in-time checks that are tied to identity. So it's, leaving behind the firewall and saying, okay, I have knowledge of who this person is, potentially from their IDP, their identity provider, and they want to connect to a resource, and I'm deciding at that moment, are they allowed to? And potentially doing things like injecting credentials and other types of checks. So, one thing that we looked at for kind of over a long period of time is, Vault is really handling the machine-to-machine interaction really well. And, it's very API driven. And, what about the human-to-machine interaction? So in a lot of cases, you sort of have, you still have humans that are either accessing Vault, but it's not super friendly for that purpose, or they're basically storing sort of like the human-oriented credentials in a password manager, and then they're storing the machine-oriented credentials in Vault. And then you still have a lot of sharing that goes on with that password manager. And so, that's a market that we looked at. We're like, okay, this is a use case, a workflow that Vault doesn't tackle particularly well. What would it look like for us to tackle this? And that's sort of the genesis of Boundary. There's, it's very early days for the product, obviously. There's a lot that we have left to do, but we have, we really want to get to that point where it's extremely easy, extremely seamless access for users to get onto services, even as it's still, entirely API oriented. It's easy to deploy with Terraform and all those other kind of things that you would expect from a HashiCorp product. So that's what I'm really excited about personally.
And yeah, so Boundary is all about administrators, DevOps, developers getting access to infrastructure. And those could be, dynamic workloads, containers, the infrastructure that's setting those things up and running and monitoring those things, or it could be very static things like routers or firewalls or bare metal servers.
Correct.
It's all about that sort of access, privileged access, and how we control, monitor, audit, track that.
Yeah, we're looking at the problem space very holistically, and so as I said, it's early days, but we really have kind of a large scope in mind in terms of the types of things that you can connect to and how you can connect to them and where you can source the credentials, such as Vault, and so on. So I think it's a really, I hope that we can build the same community around it that we did with Vault, but I think it's going to solve a lot of problems for a lot of people.
Andy, what's one thing on your radar?
Well, the one thing is probably around how does Vault simplify workloads that have inherently been very difficult to simplify. And when I say that, I think the most important one is in hardware. When we look at things like utilization of system resources like TPM chips to be able to retrieve secrets, authenticate systems from a trusted platform module, and better integrate it in with hardware, it really highlights the fact that there is still a very large world of enterprise security where things have just inherently not been simplified in any degree, shape, or form. So introducing ways for Vault to automate the process of integrating with that deep level of security hardware is important, because one of the things that's really exciting about Vault is just like there's a wide range of use cases for Vault, there's a very wide range of adversaries that our users, both in open source and enterprise, pose Vault against on a day-to-day basis. There are, for example, users today that are integrating Vault with quantum computers via the entropy augmentation features, as well as Vault's PKCS11 integration to be able to draw entropy from a quantum computer. So, that's only a few lines of changes to the stanza for Vault for the config to be able to do that. We want to bring that same level of simplicity for very inherently complex workflows to other areas of hardware security, as well as kind of enterprise grade security that's typically only seen in the Fortune 10, Fortune 5, and allow everyone to be able to have that level of security with just a few lines of text.
Yeah, kind of move it down market, make it accessible, make that same kind of strength accessible to everybody.
Exactly. Complexity breeds insecurity. At the end of the day, when I introduce complexity in any kind of security workflow, one of the things that we've learned both throughout our careers before coming to Vault, as well as we've seen firsthand within Vault, is that if you want to make a workflow secure, you have to make it as simple as possible. And this is not just a Vault thing. This is something that you see really well within Boundary as well, where you simplify the context of how do I establish session and how do I ultimately protect how users and applications communicate with an end target system. If we can simplify workflows like that, if we can simplify inherently complex workflows, we can dramatically improve the quality of security. And this is something that I know drove me to the company and that I remain very passionate about today, as well as the rest of the team, because there's so much complexity out there in security, especially in data security, that we continue to simplify for improving security, not just for Vault users, but for everyone that could be a recipient of Vault's protection.
Sarah, any of that resonate with you? What are you pushing for us to go do for you?
I mean, for us, already the integrated storage, like I said, but then having the snapshot capabilities and the backup and restore, for us, again, that just really simplifies things and makes sure that if we do have a situation where we need to get a Vault back up and running for whatever reason, maybe somebody's deleted a secret or if we just lose a Vault completely, having those backup and restores and those snapshots really help us do that in a timely manner and make sure that our workloads don't experience any downtime. Mm-hmm. For me personally, something that I'd love to see is kind of pushing that envelope a little bit with Vault. As somebody in security, Internet of Things is something that really IoT can be a little worrisome for me because there's no standard of encryption. There's no way to make sure that the information that passes between your device and your hardware is going to be secured in any manner. So what Andy's saying about leveraging Boundary and leveraging Vault to enable hardware, well, yeah, how far can we push that? Can we push that to the edge? Can we push that into the fog? And is that a way that is that something we can do with that immutable code? So for me, it's really quite interesting to hear all of you guys talk about your use cases and what you're thinking of going down the line, because then that allows me to kind of push that out and start thinking about things that I would like to see or things that I think the industry could really use in general.
That's helpful. Well, I just want to thank Sarah, Rob, Jeff, Andy so much. It's been really fun sitting with you, hearing about your stories, hearing about the origin stories, hearing about what we're able to do and getting some ideas for the future. Thanks very much, everybody.
Thank you.
Thank you.
Hey, hey.